Hello to those around the world, and especially those viewing this video. My name is Turbo, and I'm here to introduce you to my theory on handedness, and how you can determine a person's dominant-handed birth. But first, let's find out what handedness is, and how it affects our lives. Basically, handedness is the hand that you feel most dexterous with. Examples could include your writing hand, the hand you eat with, the wrist you wear your watch on, or the hand that you feel most comfortable firing a handgun with. Now, the problem with handedness is that there are 4 types: right-handedness, left-handedness, ambidexterity, and mixed-handedness. Now, my theory and the method used to determine handedness can determine several of these types with a high degree of This is what we'll be using to measure, to predict, and to determine the handedness of each individual. This is a hair spiral, and every human head on the planet has one of these on or near the back of their head. As we can see at first glance, the hair spiral spins in a counterclockwise direction, and in other cases it spins in a clockwise direction. Could this be what determines handedness? Counterclockwise for left-handed people and clockwise for right-handed people. With this method, we're still missing any indication of the other 2 types of handedness: ambidexterity and mixed-handedness. So, I think using this method is incorrect. But there is a paper published on it by some German scientists, which we will definitely get into later. Now, I have devised my own method to determine handedness, which is a totally different way from the way these others. This image is the same as before, but now we have an imaginary line down the middle of the back of the person's head. This line is not the whole method, it's only part of what is being used to measure handedness. The other part of the method involves the eye of the spiral itself, right here, which is the target point and the position of a person's dominant hand. The center line is what is used to equally define the boundaries of the left and the right hemispheric regions of the brain and the head. In this example, we can see that the subject is right-handed by the eye of the spiral, and there may be some degree of mixed-handedness as well. Now, you might be wondering how I came up with this idea to use this method. The idea came from observing the backs of many heads, including my own, since I cut my own hair with mirrors. I first noticed the pattern in my own head, and that the eye of my spiral was far to the left side of my head, and I also happened to be totally left-handed. In these images here of other subjects, we have 7 different styles of the hair spiral and in different locations for the eye itself in comparison with the center line. Now, my theory suggests that the closer the eye is to the center line, the more the degree of mixed-handedness or ambidexterity in the individual. In this one case here, the subject has two spirals, one on either side of the head, and this person also happens to be ambidextrous. There can also be a case where the eye of the spiral is in the center of the head, indicating ambidexterity in that person as well. In these examples, we have a right-handed person, a left-handed person, another right-handed person, and we've already covered the ambidextrous individual. And if you can see here, the eye of the spiral falls to the right side of the center line, making this person right-handed. This person here, the eye of their spiral, falls to the left side of the center line. And on this person here, the eye of the spiral falls on the right side of the center line. And this person, being the ambidextrous one, happens to have two spirals on either side of the head, one going counterclockwise and one going clockwise, which is a very mysterious anomaly. The best spirals to use this method with are the highly defined ones, like you see here, where the spiral can be seen very clearly and very crisply with a low amount of hair. The eye of the spiral also appears at different height levels, which may indicate the status level or the intelligence level of that person in relation to evolution. There could be a biological process in the womb that could have a connection to this observation, and it may also be able to determine right brain, left brain dominant activity just by observing the eye of the spiral. Now, there is one anomaly that can be observed while conducting this test, and that is that the eye is concentrated on the side of the head that is your dominant hand, but that side of your body is controlled by the right side of your brain. It would seem more plausible to place the eye on the opposite side of the head to match the cross circuitry of the brain. Now, there has been other research done in the area of handedness by other scientists that use the spiral to determine handedness. The title of this paper is called "The Association Between Scalp Hair Whorl Direction, Handedness, and Hemispheric Language Dominance." And the question they pose is there a common genetic basis of lateralization? Now, as we see here in this paper, if I scroll down, here's an example. I don't know if you can see it too well on the screen, but they have two hair spirals as diagrams in their paper. The two types of hair spirals shown here are typical and atypical, which is commonly known as counterclockwise and clockwise. We can go back through to read a little bit of the beginning of their paper to find out what their actual abstract states. And I will read it for you here. The hemispheres of the human brain are functionally asymmetric. The left hemisphere tends to dominate for language and superior in the control of manual dexterity. The mechanisms underlying these asymmetries are not known. Genetic as well as environmental factors are discussed. Recently, atypical anti-clockwise hair whorl direction has been related to an increased probability for non-right-handedness in atypical hemispheric language dominance. These findings are fascinating and important since hair whorl direction is a structural marker of lateralization and can provide a readily observable anatomical clue